Okay, welcome. My name is Sichinga Mastano. Make sure you subscribe to my YouTube channel so that you get notified every time I post a video. Every week we have a new video. Well, today we're going to look at limits. And what is a limit? A limit is the value that a function approaches as the input approaches some value. It is a function's value that it approaches when input approaches some value. Examples, these are the limits. We have limit x approaches 1, limit x approaches 4 for the function x squared minus 4, x minus 4. The other one of limit approaches 3 for the function x to power 3 rather minus 3x squared over 5x minus 2. Well, how do we answer this? For the first one, we replace x with 1. Okay, we have 8x plus 2. When we place x with 1, we get 8, put 1 there, then plus 2, okay, which gives us 10. So this is the value that this function approaches when this input is put in. Okay, it's just done by testing. Is this function defined when x is given the value 1? If the answer is yes, then we just plug in. That is method number 1. Question 2. If we replace x here, x with 4, you'll see what happens. In the denominator we are going to have 4 minus 4, which gives us a 0, and we don't divide by 0 in mathematics. That is undefined. Okay, so that's the hint. Replacing can't work here. We get a 0 in the denominator there, which is going to give us undefined function. So what do? Well, we are going to consider this one. Okay, well, the numerator here should be minus 16 and not minus 4. Okay, like this one, minus 16. Now when we look at this one, we consider this as the difference of two squares. Okay, because if we put 4 here, we are going to have undefined function which gives us the denominator of 0. That doesn't happen in mathematics. Okay, so when we convert this to difference of two squares, we change this, split this one, we're going to have x plus 4, x minus 4. Okay, where this and that can cancel out. Okay, so this and this goes. What remains is x plus 4. And if we apply the limit where there is x, we put 4 plus 4 and we are going to get 8. Well, now this is well defined. That's how you do the limits. Okay, so for limits you just keep checking, is this function defined? That's why we can define that as the value for which a function is defined. So you check in the denominator. On the denominator as the problem, we don't divide by 0. By no means we are going to divide by 0. Okay, a 0 on top there is fine. It just gives the answer 0. But if the 0 is in the denominator, that is undefined. So we don't replace. That's why I said replacing cannot work here. We use this method. Next question. The next question is limit x approaching 3 for the function x to power 3 minus 3x squared over 5x minus 15. Again, looking at this here, if we replace 3 in here, what we are going to have is we are going to have 3 times 5, where we get 15. 15 minus 15 is 0. Still we get a 0 in the denominator part, which is undefined. So here replacing cannot work. What do? Watch this. Well, so we just have to factorize. This is x to power 3 minus 3x squared. Looking at this one, we understand that x squared is common. We factor out x squared, that is common. We remain with x minus 3. In the denominator, 5 is common. 5 is factored out. And look at this. Well, this is nice. That's what we're looking for. So this can cancel out. Okay? We are going to remain with x squared over 5, and now we can apply our limit where we put 3 where there is x squared, we get 5, and this gives us 9 over 5. So this is our limit. Thank you for watching. Make sure you subscribe to my YouTube channel so that you get notified for every video that we are going to do. Next is looking at a better way of doing limits, and that is L'Hopital's rule. Okay, wait for the next video. Make sure you subscribe. Don't forget, share the video, like the video, subscribe. My name is Sichinga Mastano. Make it easy. Say good girl.